Hi guys, our presentation is on biogeochemical cycles. I'm Ronald, and the others in my group are Emily, Melissa, Eric, Jose, and Katie. So some facts about the nitrogen cycle. Nitrogen makes up 78% of our atmosphere by mass, so it's the sixth most abundant element on Earth. It's essential to proteins like DNA and RNA. It's also an essential nutrient for plant growth. And nitrogen gas is chemically inert, so it cannot cycle out of the atmosphere without assistance of lightning, highly specialized bacteria, and or human intervention. And this also makes it scarce in the lithosphere, hydrosphere, and in organisms.
In the nitrogen cycle, nitrogen-fixing bacteria take in nitrogen from the atmosphere in a process called nitrogen fixation. In this process, these specialized bacteria break the triple bonds that make up the nitrogen to convert it into ammonia. Not only that, but lightning is capable of splitting these nitrogen atoms. The ammonia is then converted into ammonium when mixed with water. This process helps make nitrogen available to plants. Ammonia can also be made by decomposers, fungi, and protists. Nitrifying bacteria take this ammonia and convert it into nitrates and nitrites, which is easier for plants to assimilate. The nitrates and nitrites are then taken up by plants and animals. When nitrogen-containing organisms die, decomposers convert the nitrogen found in organisms into ammonia and return it to the soil. Denitrifying bacteria converts the nitrogen oxides into nitrogen gas, thus releasing it back into the atmosphere.
So the next is the water cycle. Water is very essential to every environmental system and is a limited resource that is running low. Our oceans hold 97% of all the water on Earth, so naturally they are the main reservoirs in the hydraulic cycle. Less than 3% of freshwater, two-thirds of it comes from glaciers, snowfields, and ice caps, and less than 1% of Earth's water is usable. Water carries nutrients and sediments from the continents to the ocean via rivers, streams, surface runoff, and it distributes sediments and artificial pollutants into ocean currents. Evaporation is the conversion of a liquid to a gaseous form, so water moves from oceans, lakes, ponds, rivers, and moist soil into the atmosphere. Warm temperatures and strong winds increase the speed of evaporation too. Transpiration is a release of water vapor by plants through their leaves. Both evaporation and transpiration are natural processes that pure water by filtering out minerals. Precipitation is when water vapor condenses and falls back to earth as rain or snow. It can also be absorbed by plants and used by animals, but most flows off as runoff into another source. Groundwater is water found underneath layers of soil. The upper limit of groundwater is an aquifer that is called the water table. Aquifers hold water for a long time, so it may take thousands of years for the groundwater to recharge fully after being depleted. Groundwater also becomes exposed to the air where the water table reaches the surface, and the exposed water can run off toward the ocean or evaporate into the atmospheres. So aquifers are like sponge-like regions of rock and soil that hold groundwater. Precipitation and surface water soaks down through soil and rock to recharge aquifers.
All living things are made up of carbon, therefore making carbon one of the most abundant elements on Earth. Carbon is always on the move from one reservoir to the next. It is not just in living things, but also a large component in non-living things. In living things, plants absorb carbon and use it to photosynthesize and then respire out CO2. Most people think that plants are supposed to take in CO2 and give off O2 in respiration. This is both true and false. Plants simply give off less CO2 than they take in. The resulting CO2 goes to the plant's mass. Carbon absorbed by plants can be A. respired into the atmosphere, B. eaten by animals, C. present at plant's death. If C is to occur in a setting that will not allow proper decomposition, it may result in substances such as coal or fossil fuels. Carbon dioxide is easily dissolved in water. Once in the ocean, it is used by phytoplankton, the base of the ocean food chain. Phytoplankton uses CO2 to make their shells, and once they die, their shells fall to the ocean floor, where they gather, become compressed, and are then turned into limestone. When limestone is eroded by water, the carbon is broken down to create CO2 and carbon acid. When we burn fossil fuels, we are emitting CO2 into the atmosphere. The excess amount of CO2 is having a significant impact on the climate. The CO2 prevent some of the sun's energy from being able to move back into the solar system, thus trapping heat. These problems will only continue to increase over time. This can be in areas that are known as tundras, and they hold plants that are locked in ice, essentially frozen carbon reservoirs. As the permafrost begins to melt, tons of greenhouse gases are released into the atmosphere, thus creating a positive feedback loop. As we burn carbon, we unlock other large carbon dioxide reservoirs that further emit into the atmosphere.
Algae grow in the sea, feeding on nutrients in the water. Algae grow better when more nutrients, such as nitrates and phosphates, are present in the water column. A small increase in algal biomass has no adverse effects on the eco-column and can even lead to an increase of certain fish populations. An overgrowth, however, can lead to an algal bloom, which may disturb the water. The algae may keep out the light, and when they eventually die, they are decomposed by bacteria which consume oxygen in this process so that the water may become temporarily anoxic or hypoxia, which may be toxic to aquatic life. An enrichment by or excess of nutrients to the water is called eutrophication and may result in an explosive growth of algae. Depending on the environment, quiet bay or rough sea, and the type of algae, microscopic or macroscopic, a bloom can be observed in different forms, such as foam or green tide on the beach. Eutrophication is one of the causes of the deterioration of water quality. In the North Sea and English Channel, this is mainly due to human activities.
The phosphorus cycle is a unique and, in my opinion, a simpler cycle than the other two cycles because it does not go into the atmosphere. Phosphorus can be found in rocks, which can be released by either erosion or by mining. The phosphorus then combines with water to be taken up by plants. The plants are then eaten by animals and come back out as feces. One fun fact is that phosphorus was discovered experimenting with urine by a German scientist who thought the combination of urine and metals would turn into gold or silver. The feces, which contain phosphorus, are then broken up by decomposers, which release phosphorus back out into the land, and the cycle keeps going on and on.